And off to the side on page 516, I will get you to draw the tan graphs. So again, if we put our axis family along the x-intercept of 0, pi over 2, pi, 3 pi over 2, and 2 pi, we know that tan of 0 is 0, tan of pi is 0, but at pi over 2 and 3 pi over 2, tan was undefined. Now on the graph of tan, that shows up as an asymptote. If we want to see where does the tan graph come from? So we've got our sine and cos graphs. The tan graph, the value of the tan graph, is if you drew a tangent line on the unit circle at the point, and you measured how long that line segment was of that tangent line back to the x-axis. So if I slide it over here, see how that green line, that's the length back to the x-axis? That value is the value of tan. And so if we draw our graph as we go along, as soon as you get to 0, it doesn't exist because it never touches the x-axis. And now it's negative in quadrant 2, comes around, and back up again. So we get a third graph on here. And that's the graph of tan. And it repeats itself over and over and over again. In your textbook, they have it graphed as well, but they haven't put the axes family. Some things that are different with tan compared to the graphs of sine and cosine. For tan, it repeats itself with a period of pi. Because if you go from one asymptote to another, or as they've done here, they started at 0, 0 going up, the next time it's at 0 going up, it's shifted pi to the right, so your period of tan is pi. Now we have asymptotes at pi over 2, 3 pi over 2, 5 pi over 2. So your equations of all of your asymptotes you can write them either this way, or you can write your equations of all your asymptotes like this. And you might notice that all of your asymptotes are exactly the same as the zeros of cosine. Why does that happen? Well, tan, one of our big ideas was tan is sine over cos. So wherever cos is equal to 0, you'd be dividing by 0, which is not allowed. And dividing by 0 from your past with graphing, that often results in an asymptote. And so your tan graph has asymptotes wherever your cos graph was equal to 0. The way that we write our domain, I'll actually write it even more properly than they've done in the textbook here. We're going to use our equation of our asymptotes. We can choose either one of them and say, our domain x can't equal, I'll use the first one. Our domain is all values, but x can't equal pi over 2 plus k pi. It can't equal all of those zeros of cosine. The zeros of tan are the same as the zeros of sine. Because wherever your numerator is equal to 0, tan will equal 0. So the zeros are all positive or negative multiples of pi. It has no minimum or no maximum, so its range is everything. Example 2 looks at what happens to the period of each function. So again, what we're going to do is we're going to graph these functions and we're going to look at what happens to them. So if we wanted to determine the period of each thing here, we would say, in my transformations unit, what happens when there's a number inside the function? Anything inside the function affected it horizontally. And anything that is affecting it horizontally, in part A, where we have y equals cos of 6x, this will be a horizontal compression by a factor of 1/6. You would multiply all of your x values by 1/6. Well, if the period of my cos graph was 2 pi, it repeated itself over 2 pi, and you compressed it by a factor of 1/6, does it make sense that your new period is 2 pi over 6? Because you've multiplied your old period of 2 pi by 1/6. If we were going to graph this, instead of marking one period here at 2 pi, we'll now mark one period as 2 pi over 6. And we're still going to divide this into 4 equal sections. Now, when dividing it into 4 equal sections, the way that I would go about it is I would mark the one in the middle first. What's half of 2 pi over 6? Pi over 6. And if you cut pi over 6 in half, you would get pi over 12. Then for the third one, if one section is pi over 12, you could just count 1 pi over 12, 2 pi over 12. The third one will be 3 pi over 12. And you could reduce that 3 pi over 12 to pi over 4 if you wanted, and you could reduce the 2 pi over 6 to pi over 3 if you wanted, but you could leave it like this as well. Then for graphing cos, this graph has an amplitude of 1, so it'll still have a maximum of 1 and a minimum of -1. And your cos graph starts at a maximum. Then you go through each of your 4 sections, switching between centerline, maximum, minimum, centerline, and maximum again. And this is your graph of y equals cos 6x. So even though the question just asked us for the period, and since the period was 2 pi and we have a horizontal compression by 1/6, it becomes pi over 6. What we're going to do is we're going to start practicing graphing already, so that when we get to graphing more in the next section, we've got a good practice of it. Part B says tan of 2/3 x. This, again, the 2/3 is inside, so it's going to be horizontal. This will be a horizontal stretch. And remember, all of your horizontal things are reciprocals. So we'd multiply all of our x values by 3 over 2. Now our period of tan is pi. So if we multiplied all of our x values by 3 over 2, our period of y equals tan 2/3 x is 3 pi over 2. For graphing this, what I would do is I would start with my asymptotes. My asymptotes of tan, my first one's at pi over 2, my first negative one is at negative pi over 2. If I multiplied my x values by 3 over 2, if I took pi over 2 and multiplied it by 3 over 2, I would get 3 pi over 4. So I'm going to mark 3 pi over 4 sort of in an arbitrary spot, and I'm going to draw an asymptote at 3 pi over 4. Similarly, on this side, I'm going to mark negative 3 pi over 4 and draw an asymptote there. My graph of tan will have the same shape as it did before. There's one period. It would continue on both sides if you wanted to draw some more. But there would be the graph of tan. Finally, our last graph here, which was sine of x over 7. This is the same. Dividing by 7 is the same as multiplying by 1/7. So this 1/7 would be a horizontal stretch by a factor of 7. So if my period was 2 pi to begin with, and you stretch it by multiplying everything by 7, does it make sense that my period of 1/7 sine of 1/7 x is going to be 14 pi. I took my period, which was 2 pi, I stretched it by multiplying by 7, and now my period's going to be 14 pi. As a result, if I wanted to graph this, again, our technique for graphing will be to use our amplitude to mark our maximum and our minimum. And since there is just a 1 out in front, that value out in front will always be our amplitude. Our amplitude will be 1. So we go from our center line, which is at 0, go up 1 and down 1. Then we're going to use whatever's in front of x to help us figure out the period. The period in this case is 14 pi, so pick an arbitrary place, mark 14 pi, divide it into 4 equal sections. When labeling those 4 equal sections, start with the middle one. What's half of 14 pi? 7 pi. What's half of 7 pi? You could write 3.5 pi, or you could write 7 pi over 2. If one of these sections is 7 pi over 2, and count, 2 sections would be 14 pi over 2, 3 sections would be 21 pi over 2. A sine graph starts in the middle going up. So you just have to go into these 4 sections, go from minimum, middle to max to middle to min to middle. And there we have our graph of y equals 1/7, sine of 1/7 x. At the bottom of the page there, you've got this box which says the period of a trigonometric function. What I'd like you to write underneath it are these two formulas using whatever is the horizontal stretch or compression. We have one formula for the period for sine and for cosine, that your period will be 2 pi over your b value, because your original period was 2 pi, and then you're going to divide by your b value because that's what a horizontal stretch or compression does. You multiply by the reciprocal. And for tan, since the period started as pi, your period for tan will always be pi over your b value. And for both of these formulas, I've rearranged them to solve for b, because later on, sometimes we'll know the period and want to write the equation, so we'll have to write whatever the b value is, so we'll need those as well. Your questions for practice after example 2 are 3, C, and D.